tells us to let the f be the function defined by f of x equal to e to the x times cosine of x. So part A of this FRQ tells us to find the average rate of change of f on the interval from 0 to pi. So finding the average rate of change is really simple actually, and something we learned really early on in calculus. So it would be f of pi minus f of 0 uh, pi minus 0, right? So we just plug that in. So it'd be e to the x cosine times pi minus e to the x cosine times 0 over pi, since pi minus 0 is just pi. So what we do have to remember is that, and what we can look back to our unit circle, is that cosine of pi is equal to -1, and cosine of 0 is just equal to 1. E to the x, raised to the x, is also just 1. So our problem would end up being negative e to the x minus 1 over pi. And that's the answer to part A. So part B asks us to find the slope of the line tangent to the graph of f at x equals 3 pi over 2. So the slope of the line tangent is just the derivative of the function, which can be found using the chain rule. So f prime of x would equal to e to the x times the derivative of cosine of x, which is, whoa, a little spaz out there, another one, negative sine of x minus cosine of x times the derivative of e to the x, which is just, luckily for us, e to the x. So that's the derivative of the function. It asks us to find the value of the function when x is equal to 3 pi over 2. So all we would have to do is plug in that 3 pi over 2 into x. So that would be e raised to 3 pi over 2 times negative sine of 3 pi over 2 minus cosine of 3 pi over 2 times e raised to 3 pi over 2. Lots of pi. So negative sine of 3 pi over 2, looking back at our unit circle once again, would just equal to 1. So 1 times e raised to 3 pi over 2 is just e raised to 3 pi over 2 minus, and then the cosine of 3 pi over 2 is 0. So 0 times something is just 0. So it would just be minus 0. So then our answer would just be e raised to 3 pi over 2. And our our explanation could just be justified as the slope of the tangent at x equals 3 pi over 2 is e raised to 3 pi over 2. So section C asks us to find the absolute minimum of the value on the interval from 0 to 2 pi, and also asks us to justify our answers. So I'm just going to use the derivative that we already found from part B into this problem and to truly find the absolute minimum. So what we can do is use the candidates test uh, in finding the critical points and using the endpoints to really narrow down the minimum value. So we would have to set this derivative equal to 0, which e to the x can't really be equal to 0. So we know that cosine of x is equal to sine of x for the most part. So our critical points for this would be e or x equal to pi over 4 and x equal to 5 pi over 4. So we can just put this in a graph to make it easier for us and just lay out all of our points, our critical points and our endpoints to really break this down. So it would be pi over 4, 5 pi over 4, and finally 2 pi. So 0 into our original function right here would just give us 1. And pi over 4 into our original function would give us e to raised to pi over 4 times the square root of 2 over 2. And 5 pi over 4 plugged into our original function would give us e raised to 5 pi over 4 times negative square root over 2. And then 2 pi put into our original function would just give us e raised to 2 pi. So this looks really complicated right now, but luckily for us, we were only asked to find the absolute minimum. And right here, we can see that there's a cosine, or not a cosine, a negative sign, which means it would be our absolute lowest point, making it our absolute minimum. Now we can justify this by saying the absolute min value of f on the interval 0 to x, or 0 to 2 pi is e raised to 5 pi over 4 times negative square root of 2 over 2 by the candidates test. Find the value of the limit as x approaches pi over 2 of g or f of x over g of x, or state that it does not exist. So off the bat, we can just go ahead and directly substitute pi over 2 into f of x over g of x. So that would look like limit as x approaches pi over 2 into f of x over g of x. So f of x, as we remember, we were given right up here. So it'd be e raised to pi over 2 times the cosine of pi over 2. And then g pi, or g of pi over 2, which was given right here, and we're told that it's just equal to 0. So e raised to, or cosine of pi over 2 is just 0. So 0 times anything, remember, is just 0. So it would just be equal to 0 over 0. Now, after that, we can use the the L'Hopital rule, and that tells us that this limit right here of x as it approaches 2 of f of x over g of x is just equal to the limit as x approaches pi over 2 is equal to f prime of x over g prime of x. So that helps us break it down even further and really helps us evaluate the limit. So the f prime of x, we can go back to up here from our past parts or past sections of this FRQ and plug everything in. So the limit as x approaches pi over 2 so we would plug in e raised to pi over 2 times negative sine of pi over 2 minus cosine of pi over 2 times e raised to pi over 2. So cosine of, like we just mentioned, cosine of pi over 2 is equal to 0. So we could just mark this out. Negative sine of pi over 2 is equal to 1. So we can bring that negative out, and it would just be negative e raised to pi over 2. And for g prime of pi over 2, we can look to this graph, and which is just a graph of g prime, and go to pi over 2 right here, go up, and we can see that when x equals pi over 2, y equals 2. So we can evaluate that the limit as x approaches pi over 2 is negative e raised to pi over 2 over 2.